It's amazing, right, what he did. And he was not a computer scientist or had no training in visualization. And yet he and his son, they started this Guideminder software that Google acquired and killed and integrated in Google spreadsheets 5 years ago. And it was a pity. Google does that to many companies. They just acquire them and kill them because it was a threat to Google. Such a cool software. And it was amazing. He came out with this way to visualize things, including motion, because we humans are very sensitive to motion. And it was the first time somebody had applied motion as a magnitude to show how time passes. This is fantastic. And the way he explains it is like, here comes this country, blah, blah, blah. It's like a football match. And that helped the storytelling, because he used the football match metaphor. You know, football is a sport. It's not like, it's not a war, like a sport, so it's civilized. So countries compete in a civilized way. I thought that was a really thoughtful metaphor, and it's amazing. Did you learn anything else from the presentation or his life? No? Okay, cool. Right, so let's talk about the midterm. I guess you have questions. So how is the midterm going to be? It's going to be true or false. Very similar to the Udemy quizzes that you have. I might, for example, present some Worley map, and I will ask you what is wrong here, or what can you understand from here? And maybe there's going to be a true-false question and say from this chart we can understand this or that, true or false. Or I will show a Worley map with some mistake. For example, maybe commoditization is wrong, and it will say this is wrong. Or I will ask you, in this situation, which visual would you use? Or I will ask you, by the way, don't forget that the slides are included in the midterm. Can you see my screen?
Yes. Yes, we can.
Right. So this is the first time we offer this course, and that's why it's amazing, because it's new. But that means we don't have previous exams. So, but you have the quizzes that you have made on Udemy, so that would work very well. So don't forget that these slides, all of them are included, and maybe we didn't spend enough time reviewing them. So today I'm going to review the slides, and then we just talk about the questions in the exam, and maybe you can propose questions that you would like. And as we do in every course, if I like some of the questions that you propose, we'll add them in the exam. Okay, so here you have some basic theory of marks and channels, and this is a graphical aspect of scientific data visualization. So you can visualize data with points, line, areas. Yeah. You can use the channel to control the appearance of a mark. So you can control position, size, shape, tilt. Right? We are very sensitive to tilt, by the way. Do you know that? Did you know that? Orientation.
Yes, you told us, I think, before.
I told, yeah. No. So here's the color as well, except blind color people, right? So many different ways you can express things, but there's nothing more. That's it. This is all we have. And semiology, does anybody know what semiology means? Semiology is the science that studies symbols. Symbol is an object that represents another idea. So here you have the work by Stolte and Hanrahan, and so you have mapping between property and a graph, right? So you have ordinal mapping, so categories, no? So you have different categories. This could be different countries, different, or you have quantitative mapping. So categories cannot be mapped quantitatively, but numbers, yes. So that's interesting. They have progression, and here's about how the brain works. If you understand how the brain works, you might be able to design better charts. So as you know, all your visual processing is done here. And that's why people, when they hit here, they lose the vision. So this chart is about, this slide is about what versus how much. So for categorical things, you can use shape, position, color. And for how much, you can have quantitative or ordinal things. So you can have the length, right? Area, volume, right? So you saw planetary charts, very good use of volume 3D, tilt and position. You can skip that one. And here you have two things you need to know. This is a bit from psychology. So you have the expressiveness principle. And this means that the encoding, so the way you show the information, should express all of and only the information in the dataset attributes. So you should not lie. That's what it means. And the other is the effectiveness, that the importance of the attribute, so do you use red color and it's justified or not, should match the importance, should match the salience. Salience means how sensitive we are to it. And there's another thing called data to ink ratio. I think we talked about it, that if you have a chart and there's a lot of black, it doesn't look good, yeah, and so on. So these are things that have been studied a lot in graphic design, but that we don't teach in computer science. But there's a whole, so there's people that study this only as a career. Then there's a thing called effectiveness of mapping. So some mappings are more effective than others, of course. And you can use this to your advantage or to lie or to misinform, right? And that's why it's important to know about them, to be more ethical. All right, so it's better to see with examples. So that's what we saw the other day here. Remember this chart? Yeah. So using color, red color, or using grayscale, or using brightness. So it has, have different sensitivities. So is it appropriate to use such a sensitive channel for something that is not important or not? So that's very interesting. Right. For example, there's another thing called discriminability in a chart. And this has to do with the cluttering of the chart. So if we use colors to distinguish countries, for example, and you have two countries and I use red and blue, it's okay, right? But if I have 250 countries like the United Nations, and I use colors to distinguish the countries, can you distinguish 250 colors?
No.
Some people do, and they're very well paid, but I can't. Women are better at this than men, but I can't. So that's a problem, and it has to do with also cluttering. There's another, so this is discriminability, no? So be careful with that. Separability. And this has to do with like you have some channels that are fully separable and channels where there's a lot of interference. For example, if you choose red and green, like here, red and green, and you have other colors that are similar, you have interference, right? So it's not very good. But here it's very good, right? Because I can use position to separate things and I can use color to separate things. But here, oh, right? So this channel here, not separable, is not very good. Here is much better, right? So the choice of colors affected how the separability is. So that also affects. Right. So there's a lot of research on which kind of color palettes, color choices are better or not. And this is a job that has been done for you, so you don't have to reinvent the wheel. And that's one of the reasons we say, if you're not a color expert, don't use more than 2 colors to be safe, okay? Because otherwise, not only the cultural things, but also all these possible problems. And also that you don't control the medium that the people will read your chart. Like what if they read it on a very poor screen on a mobile phone or a printed newspaper? It's never controlled. It's always good to be on the safe side. And so on. Here's the same, that we process color much faster than shapes. So for example, here, can you find the odd one out? It's this one, right? The red dot. Here, red dot. Here, which one is the odd one out? It's this one, right? It takes more time. So we're very good at separating by color. We're very bad at separating by shape. Why is that? It has to do with our brains and with our eyes, right? So color, we separate here from the eye directly. So it's already separated when it reaches the brain. But our eye doesn't process shapes, complex shapes at eye level. So the information has to travel and the processing is done here. That's why it takes so much more effort. Make sense? So this is what we saw. And here's some slides about the visual system. Maybe if you do computer graphics, the previous to this one, you have already seen. But this is super interesting. It's like, this is frequency. And as you can see, we are very sensitive. We see a lot of red, but blue, we're not very good at seeing blue, right? So we're almost blind to blue light. And we're very sensitive to red, to green and red. And we see more red than blue, for example. How is that possible? And why is it not distributed the same? Well, it has to do with physical properties of our eye receptors and so on. So the eye receptors are super complex, as you know. We have various types of receptors, and all this explains why we see things differently. The way we see them, and it explains also optical illusions. There's a lot of processing going on in the cornea already in the eye. There's a lot of signal processing, like angle of shapes and stuff like that, and derivatives of between spatial derivatives. For order spatial derivatives happen in the eye, which is incredible. So all this is a fascinating topic. Here's what I was saying about why we see red and green so much better than blue. And well, it has to do with physics of our eyes. There's another theory about opponents of colors, which colors are opposed to other ones. And then you have all these color models, right? But as I say, to be safe, don't use too many colors. And then all this is good to know. The color space, HSL, maybe if you use Photoshop, you see that. And the lab color space, all that stuff. There's a few things you should know. The difference between luminance, saturation, and hue. So luminance is how much photons you get. Saturation is how much color instead of gray you have. And here's which color, yes? And so, and this is the discriminability for our human system. So you can have like 2 4-beam, 3-beam, 6-beam. So for example, if you have 3 classes of data and you discriminate by luminance, this is how it looks like. By saturation, this is how it looks like. Yeah? Complete red, no red. By brightness, this is how it looks like. Which one do you like? Which one do you think is better? Use it. Nura? Anybody? Yeah.
I think the second one is better, in my opinion.
To discriminate between 3 classes? Okay. Why would you choose that one?
Yes, because I mean for women, because the men maybe they have what they call
men are colorblind.
yes, the color of lines. So I think for them is the luminance is better. Right.
Okay. Anybody else has an opinion?
Same as Raya, the saturation one.
Women banding together. Okay.
Thanks, Hanan.
Great. Yes, somebody else?
I feel saturation is good.
like the other women. Okay, somebody else? The Shire. Anybody else wants to say something? Okay, so I prefer luminance because your eyes get less tired. So if you have to watch a chart for 1 hour and it's grayscale, you can watch it. But if it has a lot of color, you get so tired.
I thought we were actually talking about dresses, not about colors. But okay.
Right, so if you use saturation, like in this case, and you have to watch this for 1 hour, you just can't do it. I can do it. You get really tired. That's why if you go to the police departments, the people that control the traffic and they watch TVs all the time, and the security guards, have you seen they have color screens or gray and scale? What do they have?
A red light?
The security guards that watch,
They have a green screen, no color.
not color, but they are not
okay.
poor. Do you know why is that? Why do you think is that?
As you said, if they watch like saturation color, they will get tired.
If you put a security guard on a color screen monitor, after 1 hour, he's crazy. He will go mad, crazy. He's just like,
Really?
not 1 hour, but 8 hours. They get tired much faster. Their eyes get tired much faster. If it's grayscale, because the way our eyes are built.
No wonder why the guys leave the girls. They wear so much colors.
Okay, shut up, Yusuf. So the cone cell and the color cells, they are different cells. And for whatever reason that I don't understand, but maybe we can ask some biologists. For some reason, when we watch highly saturated things, we get more tired. We have to process more things and so on. More primitive animals don't have color. So maybe it means that color is a more evolutionary, sophisticated thing that requires more energy to process. Yep. Good. That's a very good question. Why? Another one. How do you like this one? What is this?
Doctor, are you wearing black intentionally?
Absolutely. I'm wearing black because my dark soul. My
Oh,
soul
okay.
is dark
Okay.
as the black color. Right. Okay, look at this. Can you tell me if they use luminance, saturation, or brightness here to distinguish the classes?
Luminance?
Somebody else?
You mean these are bright color actually. The colors are bright themselves.
Some women that is not colorblind can tell us, did they use luminance, saturation, or brightness to distinguish the classes here?
Okay.
Yusuf, try again. What changes here? In other
Nothing.
words, no. What is constant? The luminance, the saturation, or the brightness?
Wait, show me. I'll see. I feel it's the first one.
The brightness is fixed.
So I would say that if I convert this to gray, the brightness is the same, right? So the brightness doesn't change. Luminance, does it change? No. So what changes? It changes the hue only, and the saturation is constant, and the luminance is constant, yes? That's why when we convert to grayscale means we convert everything, we get rid of the color, we cannot see the difference. That means that the only change was the hue, the color, and the luminance and the saturation were constant. Does that make sense? Yes?
Yes.
Yes.
And so if you make a chart with these colors, which are very nice, they look fantastic, beautiful, right? Look at this, it matches my library here, right? It look like $1 million.
Yes.
And then you do this in a paper, and then this paper gets printed in a black and white printer. What's going to happen with your chart? Becomes
Good luck.
useless, right? So be careful with that. Be careful with using cute colors. Another one, I take off the hue, the channel color, boom. I don't see it anymore. You see that?
Okay.
Right. There's people that have deficiency. So what does it mean? 8% of all men, they don't see well, but women much better. Yeah. And here, if you want to simulate how these colorblind people will see your charts, so 8% of the men, you can go to this website and this website. Good to know. Good. Colorblindness. So this is how colorblind people see things. So it becomes when you're missing one of the color detectors. Sounds good? And if you choose a cute palette like this one on the left, and this is how the colorblind people see it. So this color palette is beautiful, but think about the people that are not color. So using color, that's why I'm not a fan of using color, because you already have a lot of work visualizing data and so on. So why get into the color morass? Yeah, well, that's very interesting. Sounds good. Good. Okay. So we saw this. We saw this. There's another thing called relative versus absolute judgment. So this is law in perception that says everything is relative. It means that the intensity of the background depends on what you have in the background. Yeah. Sounds good.
Yeah.
Good. And here you have an optical effect, which explains the Weber optical illusion. So which, do you see this?
Yes.
Yes.
So actually these 4 stripes are exactly the same.
No, they are not the same.
Exactly. So put your fingers between any 2 of them and you will see how they are the same. Put
They
your
are
finger.
the same, but the background is different.
And
The,
that's why they
the
look
position of the strip is different. Like,
so it's an example of Weber's law where the intensity, in this case, the luminance, depends on the background. And you can see that. And why are we so stupid as humans like that? It's not about that. It's that these were super useful when we were cavemen and we had to see a lion coming to us in the middle of the night. Sounds good?
Wow.
Here's another famous one. A and B, which one is gray color is darker?
Eh,
So after getting know about this law, I got confused.
A and B is the same gray color or not?
No.
no.
As
Well,
we can know.
is a right. So if you go to this website, this is called the Optistatum, and I have to show it to you so you believe it. Otherwise, you will not believe me. That's the problem with optical illusions. So also, it's good to know these optical illusions because if you make a chart with gradients and stuff like that, you can use or misuse the optical illusion to misinform, even though the chart is technically correct. Right, so here you have the complete explanation. This guy studied optical illusions. All of these are the same. And you have so many examples. This one is example that A and B is the same gray color. And here you have an animation to show it to you guys. You see it's the same gray color? You see it?
Mm.
Amazing or not? How is this possible? Yeah? Well, it's because the way our eyes are built. There's a lot of signal processing happening at the eye level. Not conscious. We don't access it. The information comes processed to the cognitive area in the brain. And that's why we see what the information we get because it's pre-processed, because it was useful. It's the way it's built our brains and our eyes. Sounds good? Good. There's a whole wall of optical illusions. If you discover a new optical illusion, you'll be famous and get your name on Wikipedia. It's another one, very famous one. There's another one. Like, which one is bigger? Well, both are the same size.
Same size.
Same size. Incredible. A moon. Look at this. With humans, when we see a moon close to the horizon, we feel that the moon is bigger, even though the moon is always the same size. And this effect happens even in photos. So what's going on, right? Why is that important? And so, and so, and so, and so on, and so on. Yeah. Right, so fascinating wall of illusions. So many. Good. Okay, so be careful with illusions. Be careful with using color in your chart.
Yeah, I have another example. I can share it if you want.
Share it on Slack, please.
Okay.
You want to share your Zoom screen?
What's the name of this course?
VIZA, visualization, VIZA. V, the one with a V. How many Slacks do you have?
I'm done. I sent it. Wait, no.
Who do you send it to?
Wait. Yeah, now I can see it.
Beshai, okay, can you explain this?
I think because of the color that we shine on the objects, it's all the same color actually. The car, all of them is are gray, and we shine different colors. And as you can see, if we shine green and gray, it looks like it's red. But actually, all of them like the same.
Fantastic. Very good. Very good. Wonderful. So illusions. So be careful in your chart. If your chart, for whatever coincidence reason, is prone to an illusion, what should we do? Should you change it so you break the illusion? Or you should keep it, that's the data, I'm sorry. It's an ethical dilemma. Should you change the data? So
when you want to give about a data that is actually bad, so you create an illusion that it looks good. This is what you do to your boss.
So, okay, so let's say you have a chart and you know there is an optical illusion there that makes the chart misrepresent the data. So you know that people that see the chart will think something else than it actually is because you use some color palette or whatever. What should you do?
If I am not ethical, like my doctor.
No, you are my student. What should you do?
Okay, if I am ethical, I will change it. I'll make it good chart.
Change the type of chart?
The illusion, the things that create the illusion.
So you will modify the actual data, so you break the illusion, but what people will see is what they...
No. If I will change just the type from circles to bars or something different.
Interesting.
Yeah, because many things will not represent an illusion.
Yeah. So this is very interesting, Colonel. So my advice is change the type of chart so you don't have illusions haunting you. Wonderful. Right. Okay. So that's it for this and the midterm. As I said, yeah. If you want to propose questions that you think would be useful for the midterm, let me know. And I will prepare some mock-up questions tonight. And midterm will be maybe 20 questions and long questions. So the questions will be long. And then you have multiple choice or true or false, as I said. Yeah. So...
Can you send this slide right now just in Slack so it becomes on the main page?
Sure. You have all these on Dropbox as usual, but yeah, sure.
But I mean, instead of going tick, tick, tick.
Yes. So let's see.
The slides that are coming in the
And doctor,
There you have it, Joseph. Yeah.
could you please enable the backtracking in the exam?
No backtracking.
Why?
Okay.
Is this with camera?
Do you know the saying that safe boxes help honest people stay safe, stay honest? Yeah. You know, the safety boxes help honest people stay honest. So backtracking helps students stay honest. No backtracking.
Camera? If it
Do
is
you
with
agree?
camera? No, I don't agree.